Hey there, cosmic explorers. Welcome back to our channel. Prepare to have your mind expanded as we embark on a journey through the vast starry sea of the universe. Imagine, if you will, all the beaches on Earth. Each grain of sand, a tiny speck in the grand scheme of things. Now consider this. There are more stars in the universe than all those grains of sand. Mind-boggling, isn't it? And that's just the beginning. Our journey takes us through galaxies, vast cosmic structures that house these stars. Among them is our very own Milky Way, a spiral galaxy that's home to our solar system and billions of other stars. Each star a world in itself, a beacon in the dark expanse of space. Such is the grandeur of the cosmos, a testament to the infinite wonders that lie beyond our world. Our Milky Way galaxy alone contains billions of stars. And speaking of stars, those mesmerizing nebulae you see in pictures aren't just pretty clouds, they're much more complex and fascinating than that. Nebulae, to put it simply, are cosmic nurseries. Yes, you heard me right, nurseries. But instead of babies, these nurseries are busy birthing stars. They're massive, sprawling clouds of gas and dust, some spanning hundreds of light years across. Inside these colossal clouds, the gas and dust start to clump together under the force of gravity. As these clumps grow denser and hotter, they eventually ignite, giving birth to a brand new star. This process can take millions of years, but the end result is well worth the wait. From the ashes of gas and dust, a radiant glowing star is born, ready to light up the cosmos. So the next time you look at a nebula, remember, it's not just a cloud, it's like a stellar nursery out there. Now let's talk about black holes. These are not your everyday cosmic phenomena. They're regions of space where gravity is so potent, so overwhelmingly powerful, that nothing can escape their pull. Not even light, the fastest thing in the universe, can outrun a black hole's gravitational grip. Imagine a star much like our own sun, but many times larger. When such a massive star exhausts its nuclear fuel, it collapses under its own weight. This collapse triggers a supernova, an explosion so bright that it can outshine an entire galaxy. But what's left behind is even more fascinating, a black hole. These black holes are invisible to the naked eye. They're cloaked in a boundary called the event horizon, beyond which we cannot see or gather information. Within this boundary, space and time as we know them cease to exist. They become a singularity, a point of infinite density. These cosmic enigmas challenge our understanding of physics. They're a testament to the mind-boggling complexity and beauty of our universe. But the universe has surprises in store for us. Beyond the confines of our solar system lie realms we're only beginning to explore. These are the exoplanets, celestial bodies that orbit stars other than our sun. They're not just a few, but thousands of them, each unique, each a world of its own. Some are gas giants, dwarfing our Jupiter, while others are rocky like our Earth. And here's where it gets exciting. Some of these exoplanets orbit within their star's habitable zone, the so-called Goldilocks zone, where conditions might be just right for liquid water to exist. And where there's water, there could be life. Scientists are using advanced telescopes to delve into these distant worlds, looking for signs of life. So who knows? The universe might be teeming with alien life, waiting to be discovered. It's a thrilling prospect that redefines our place in the cosmos. E.T., are you out there? Hold on to your helmets because we're about to take a trip to the largest volcano in the solar system. Let's shift our gaze from the starry expanse and zoom in on a familiar red dot, Mars. This crimson planet isn't just known for its potential to host life or its daunting dust storms. Mars is home to a colossal marvel of nature, Olympus Mons, the largest volcano in the solar system. This towering giant stretches a staggering 22 kilometers high, dwarfing our Earth's highest peak, Mount Everest, which stands at just over 8 kilometers. That's right, Olympus Mons is about 3 times the height of Mount Everest. But the size isn't the only thing that sets Olympus Mons apart. Unlike Earth's volcanoes, which are created by tectonic plates shifting and colliding, Olympus Mons formed because Mars doesn't have tectonic plate activity. This lack of movement allowed lava to flow from the same spot for millions of years, building up this massive mountain. So next time you look up at the night sky, remember there's a mountain out there on Mars that's 3 times the size of Mount Everest. Olympus Mons stands about 3 times the height of Mount Everest. Ever wonder how it all began? Picture this: a point of infinite density, a singularity smaller than the eye can see. This was the birthplace of our universe, according to the Big Bang Theory. It suggests that about 14 billion years ago, this singularity began to expand, and as it expanded, it cooled and formed into what we know as matter. This wasn't an explosion in the traditional sense, but rather an expansion of space itself. It's like baking a raisin loaf. As the dough rises, all the raisins move away from each other, but they're still part of the same loaf. In the same way, all the galaxies are moving away from each other, but they're still part of the same universe. And just like that, from a tiny, infinitely dense point, the vast, ever-expanding universe that we are a part of today started to take shape. And from that tiny speck, the entire cosmos unfolded. Thanks to remarkable telescopes like Hubble, we can peek billions of years into the past. This might sound like science fiction, but it's a fascinating fact of astronomy. Telescopes are our windows to the universe. When we observe distant galaxies, we're not seeing them as they are today, but as they were when the light we're now seeing first started its journey. This delay is due to the finite speed of light. It takes time for light to travel from these distant cosmic objects to us. So the further away an object is, the further back in time we're seeing it. This means that telescopes like Hubble allow us to look back in time, witnessing cosmic events that occurred billions of years ago. So each time you gaze at images captured by these magnificent instruments, remember, you're not just witnessing the vastness of space, but also the grandeur of time. That's like time traveling through light itself. So there you have it, fellow space enthusiasts. We've journeyed through a universe teeming with more stars than grains of sand on Earth. We've witnessed the birth of these celestial bodies within the sprawling cloud nurseries of nebulae. We've grappled with the perplexing enigma of black holes, where not even light can escape their gravitational grip. We've pondered the possibility of life beyond Earth as we explored the intriguing world of exoplanets. We've scaled the towering heights of Olympus Mons on Mars, the largest volcano in our solar system. We've traced back the origins of the universe to a single point of infinite density, the Big Bang. And we've time-traveled billions of years into the past, thanks to the marvel of telescopes like Hubble. This cosmic journey has only scratched the surface of the incredible wonders the universe holds. The cosmos is a playground of mysteries, waiting for us to unravel its secrets. Keep gazing up at the stars and keep dreaming big.